be pleased to know that we've actually already done this. In the last video, I showed you a unit circle. I think we used this angle here, 5 pi over 6. We used the fact that the reference angle for 5 pi over 6 is 5 pi over 3. 5 pi over 3. But the reference angle for 5 pi over 3 is pi over 3. So we have here pi over 3. We found its coordinates were cosine comma sine. Cosine is 1/2. The sine is √3 over 2. So the coordinates for 5 pi over 3 were 1/2 comma negative √3 over 2. And from that, we were able to say, this is the sine, this is the cosine. Tangent was sine over cosine, and then we simplified that. Actually, I'm pointing at the wrong one because I'm looking for the sine, cosine, tangent, cotangent, secant, and cosecant of this angle, which, by the way, is this angle, right? But I'm using the reference angle of pi over 3 to do it. So I should be pointing at this angle here and these coordinates. The sine, cosine, the sine of this angle is negative √3 over 2. The cosine is 1/2. The tangent is this number divided by this number, y divided by x. The cotangent, I think I said tangent just now. I hope I said tangent. Tangent is sine over cosine, or y over x. Cotangent is 1 over that, or the reciprocal, so just x over y, or cosine over sine. The secant is 1 over the cosine, so 1 over this value, and then the cosecant is 1 over y, 1 over sine, so it's 1 over this value. So that's how we found those, and we did that already in the previous video. Something that the book has not shown you yet, but that I have, is that the coordinates in quadrant 1 are always both going to be positive. So you're going to have a positive x and a positive y. In quadrant 2, your x is going to be negative because in order to get to a point on the unit circle in quadrant 2, you have to go to the left. These are negative x values here. And then positive y. So negative comma positive. In quadrant 3, you have to go left and down. And in quadrant 4, you go right and down. So positive, negative. And there's a mnemonic. I'm sure there are many, actually. The one in your textbook is not as familiar to me, so I'll explain what it is, and then I'll tell you what mine is. All functions, all trigonometric functions, all of them are positive. In other words, both coordinates are positive in quadrant 1. Let me, in fact, put a little 1 here. So we remember that we're talking about quadrant 1. Here we'll be talking about quadrant 2. Here is quadrant 3 and quadrant 4. Looking just at quadrant 2, between sine and cosine, this is cosine and this is sine because that's how we just established what sine and cosine were. The cosine is the x-coordinate, sine is the y-coordinate. Cosine here is negative. The only thing that's positive here is sine. So I'm going to put an S here to help me remember that sine is positive. Now, remember that if you take, let me get a pen again, if you take a fraction a over b and you want its reciprocal, you end up with b over a. If the fraction starts out positive over positive, then the result is also going to be positive over positive. If the fraction starts out a negative over a negative, which by the way is a positive, then the result will also be a negative over a negative. If the fraction starts out negative over positive, that's a negative, because it's negative divided by a positive is a negative, and you flip it over, you're going to get a positive over a negative, but that's still negative. And if you have a positive over a negative and you flip it over, that's a negative by the way, then you're going to get a negative divided by a positive, which is also a negative. So the sign, S-I-G-N, the sign of a fraction does not change when you flip it over, right? When I flip this over, I'm going to get a positive number. It's not going to be a half anymore, but it's still going to be positive. Okay, so because these are all fractions, they're all rational numbers, right? They're all ratios of two numbers. When I flip this over, I'm going to get 2 over the square root of 3, but it's going to stay negative. Now, the reason I'm mentioning that is that since the sine is positive in quadrant 2, so is the cosecant. Because the cosecant is 1 over the sine. To get the cosecant, you flip over the sign, and so the positive negative sign stays the same. So when I write s here, what I'm doing is reminding myself that sine and its cousin 1 over sine are positive in this quadrant. Now I'm going to skip to quadrant 4 for the next one because here it's really obvious that the cosine is positive and the sine is negative. So I'm going to put a reminder here, a big C, that reminds me that cosine is positive. And if cosine is positive, so is secant, because secant is 1 over cosine. If I flip over cosine, if it's positive, then its cousin 1 over cosine, secant, will also be positive. Now what I have so far is that all trigonometric functions are positive in quadrant 1 because sine is positive, cosine is positive, tangent, which is sine over cosine, is positive. That's a positive divided by a positive. If tangent is positive, 1 over tangent or cotangent is positive. 1 over sine is positive, that's cosecant, and 1 over cosine is positive, that's secant. So they're all positive, not just sine and cosine. Sine and cosine are positive, but so are all the others because of their relationships to these two. In quadrant 2, only sine and its cousin 1 over sine are positive because cosine is negative, 1 over cosine is going to be negative. Tangent and cotangent are either x over y or y over x. So x positive over negative or negative over positive, that's going to give you a negative. So cosine, tangent, and cotangent are, and let's see, cosine, tangent, cotangent, and secant, which is 1 over cosine, 1 over a negative, those are all negative. So the only relations, the only functions in quadrant 2 that are positive are sine and its cousin 1 over sine. In quadrant 4, we have cosine is positive and sine is negative. Cosine is positive, so 1 over cosine. That's secant. That's going to be positive as well. Tangent, though, is sine over cosine. That's a negative over a positive. Cotangent is cosine over sine. That's a positive over negative. Both of those are going to be negative. Cosecant is 1 over sine, and that's a 1 over a negative. So those are all negative. So the only things that are positive are cosine and secant. In quadrant 3, we have sine is negative, cosine is negative. 1 over sine will be negative, that's cosecant. 1 over cosine will be negative, that's secant. What's left is tangent and cotangent. Tangent is y over x, which is sine over cosine. That's a negative divided by a negative, and that's a positive. So in quadrant 3, tangent is positive. And since tangent is positive, 1 over tangent is positive, and that's cotangent. The mnemonic that your textbook gives for this is all smart trig class. That doesn't make any sense to me. I mean, what is that? It doesn't mean it's not a sentence. It doesn't mean anything, right? The one I grew up with and the one that I think most of the students that I have ever spoken to with know this mnemonic. All students take calculus. Now, that may not be a true statement. Obviously, not all students take calculus, but it's a sentence. It makes sense. Hopefully, that will help you remember. What you do have to remember is that you start in quadrant 1 and go around quadrants 1, 2, 3, and 4. All students take calculus. The thing is, you don't really need to remember this either. You don't need to memorize it, rather. What you need to know is that a coordinate in, say, for example, quadrant 4, is going to have a positive x and a negative y. So those are your signs for this. And then everything else that you need is going to come from the fact that whatever point you have in this quadrant is going to be equivalent to a point in quadrant 1 with potentially different signs, SIGN signs. All right? Now, I finally managed to finish a video in under 10 minutes, so I'm pretty excited about that. In the next video, we're going to be talking about using the ideas of odd and even functions to help us with some of this evaluation. I'll see you over there.